Hi and welcome. Today we'll be talking about algebraic expansion. So what's algebraic expansion? Well, let's look back to what happens when we multiply variables together. What is x times y? Well, it's pretty simple. Based on algebraic notation, we'll just say that this is equal to xy. But let's think of this in a different way. Let's visualize it. Let's say I have a rectangle where the length of the rectangle is x units, while the length of the breadth of the rectangle is going to be y units. So what's the area of this rectangle? Well, it's going to be length times breadth, x times y, which is xy. Pretty straightforward. But what happens when we have, let's say, a times x plus y? What would this be equal to? Is it ax plus y? Is it ax plus ay? We don't know. Well, let's find out. Instead of thinking just purely on algebra, let's visualize it. Using the same analogy, let's draw a rectangle. This side right here is going to be a, while this side right here is x plus y. Let's break this rectangle into two pieces. Something like this. So this whole length right here is going to be x plus y. But let's break it down into two pieces such that this side is x units long, while this side is y units long. We didn't change the area of the rectangle, we just broken it down into two pieces. So, what's the area of this rectangle right here? Well, it's going to be a times x, which means that it's going to be ax. What about this rectangle right here? Well, it's going to be a times y, which we know that is equal to ay. Since we said that the area of these two rectangles is the same as the area of the whole rectangle, it means that the area of the full rectangle is equal to ax plus ay. Which means that this thing right here, a times x plus y, is equal to ax plus ay. Okay, so how about let's try something else. What happens when we have a times x minus y? What would this be equal to? Well, same thing. Let's draw a rectangle. This side, the breadth is going to be a, while this side is going to be x minus y. Let's extend the rectangle. Let this whole length be x, while this length right here is y. You can think of it as I'm having a larger rectangle and removing a part of it. So when I have this full rectangle right here, and I remove this part right here, I end up with my original rectangle right here. So what's the area of the full rectangle? Well, that's going to be a times x. So that is going to be ax. What about this region right here? How much of it am I removing? Well, as we know, this is a because it's a rectangle, so it's going to be a times y, which is ay. So, what does it mean? Well, what's this area then? We said that this rectangle right here is the full rectangle subtracted by this part, because we're removing this part. So the remaining rectangle, the part that we're interested in, is going to have an area of ax minus ay, which means that a times x minus y is equal to ax minus ay. Now, let's go back to the previous parts. We see that each of these things right here within the brackets magically gets an a that was outside of the brackets that's being multiplied. Same thing here. X and minus y all get an a, as you can see right here. This is called the distributive law. If we have a times x plus y, this is going to be equal to ax plus ay. It doesn't matter if it's x plus y or x minus y, because we could let y be equal to negative y. What do I mean? Well, if we let this y be equal to negative y, well, it's going to be a times x plus negative y, which is equal to a, which according to the distributive law is going to be equal to ax, oops, not this color, ax plus ay. But y is equal to negative y, so it would be plus a times negative y, which is equal to negative ay, or minus ay. This part right here can be reduced into just a simple x minus y. So here it is. Here's how you expand multiple things inside a bracket when it's being multiplied by something else outside of it. How do you remember it? Well, how I like to think of it is this. First, let's consider x plus y. It's pretty similar for x minus y as well. We box up every single term within the brackets. I recommend you also box up the plus or minus signs before each term. Next, circle the thing that's outside the bracket that's being multiplied into the bracket. Next, distribute this thing into each of the boxes. So we have a and x being distributed to x, so it's ax, being distributed to y, so it's ay. Now, what happens when we have this? What is this equal to? Well, we know that if we have two things being multiplied together, like a and b, it's the same as b times a. So this actually is the same as a times x plus y. So it's the same thing. So if you encounter such a situation, don't be afraid. Now, let's try a few problems. First, what is n plus 3 in brackets times 2? Well, like I said, whenever you have something, this one thing, on the other side, don't be afraid. You can always rewrite this expression as this. Remember, a times b is the same as b times a. So, let's see what we have to do. First, box up whatever's inside the brackets that have inside the brackets where there are multiple terms inside the brackets. In this case, let's box up whatever's here. And again, let's box up the sign as well. So we have n and plus 3. Next, circle the thing that's being multiplied. Technically, we can remove the brackets, and maybe it will look clearer. We are multiplying this bracket by 2. Third, let's distribute this 2 into each of the brackets, into each of the boxes, I mean. So what do we get? 2, and it's being distributed by n, so it's 2n. 2 is also being distributed to plus 3, so it becomes 2 times plus 3, which is plus 6. And that's your final answer. Let's try a different problem. What is 6 plus 4 times x minus 3? Well, let's do a similar process. Box up whatever's inside the brackets that has multiple terms. So we have an x and a minus 3. Next, circle the thing that's being that's being multiplied by the brackets. Is it 6 or 4? Well, 6 is not being multiplied by the brackets, so that is not what we are distributing. An easier way to think of it is just look for the thing that's directly to the left of the bracket, which is 4. But I also recommend you to box up the plus sign as well. We'll see why later. Distribute this thing into each of the boxes. So what do we get? Well, we get plus 4 times x, which is 4x. We get plus 4 times minus 3, so it's minus 12. But don't forget we had a 6 at the beginning. It's technically a plus 6, so we have here. We're just going to add these things together. And this is our final answer. Remember, the thing that you're distributing to the boxes in the brackets is directly to the left of the bracket. Now, let's look at one final problem and why I recommend you to box up the signs as well. What is y minus 4x minus 2y plus 1? First things first, we have a situation right here. What? Why do we have like multiple things inside a bracket and where's the number? Well, actually, realize that when we have a minus something right here, there's an invisible number 1 here. So actually, it's just y minus 1 times 4x minus 2y. Okay. So first things first, as usual, box up every single term in the brackets, include the signs. Next, circle the thing that's being distributed, so that's directly to the left of the bracket. I recommend you include the sign, so it's a minus 1. Next, distribute each of these accordingly. Now we have a y and a plus 1, so let's not forget about them. So we have a minus 1 times a 4x. Minus 1 times 4x is minus 4x. Next, we have minus 1 times minus 2y. Two negatives multiplied together make a positive. So this is equal to positive 2y. Don't forget we have 1. And this is our final answer. Oops. Well, that's pretty much it. I hope you have enjoyed, and thank you so much for watching, and I'll see you guys next time.